Hello, everyone. Welcome to the Safe House, brought to you by the SafeHouse Initiative. I'm Jeff Edwards, co-chair of the SafeHouse Initiative, and your host for today's podcast. Welcome back to the special edition series of the Safe House, based on the book by Roger Grimes, Data-Driven Computer Defense. The last episode, we had the opportunity to get acquainted with Roger as he introduced us to the contents of the Data-Driven Computer Defense. The 13 chapters of the book are organized into three parts: root causes, mental maps and operational frameworks, and implementation examples. Today's episode, Roger is delving into root causes. Over to you, Roger.
Yeah, so I really address two types of root causes in it. The first root cause I address is, I'm talking about everybody's defense is just not, or most people's defenses are not correctly risk aligned. Again, two things: social engineering, unpatched software, firmware are responsible, at least today, and have been for decades, a huge part of the problem. But most organizations don't spend even 3% of their time or resources addressing those two issues, even though it's 99% of the problem. And so one part of the root cause is like, why did it get this way? People don't want to have bad risk management. They don't want to do cybersecurity defense, inefficiently. So one of the root causes is, well, how did it get this way? Nobody wants to do it wrong. And I said, well, because I had to think about that. I tell somebody, you need to, whatever the problem was, you need to patch Java, you need to fight, so whatever the problem was, I would tell them, and rarely would they actually address that. Yeah. So that really perplexed me. And it was wild because even the person in charge sometimes would be fired or move on to another job. There'd be a new person come in. And I'm like, all right, they're going to see the problem, hear the problem, they're going to tackle the problem. Nope. Yeah. Just one company in my entire career ever did it right. And I'm like, why are they all getting it wrong? And it really came down to the core root cause was, man, there's a lot of ways you can be attacked. There's just a ton of attack types out there. There's at least 13 different root causes of hacking that we'll talk about shortly. But there's, last year, there's over 29,000 different public vulnerabilities announced that, if you had that software firmware in your environment, you had to go patch. There's hundreds of millions of malware programs, unique malware programs being made every year. There's all these attackers and ransomware people trying to break into you. So there's just a sheer, and you're told to be worried about everything. Not only viruses and Trojans and ransomware, but, Internet of Things, encryption attacks, insider threats. And so you end up being told, let me say, and if you look at all the different cybersecurity frameworks, they're trying to protect you against everything. And what they come back with is like 200 to 300 controls. You got to have firewalls, you got to have antivirus, you got to have logging, you got to, So a big part of the root cause is there's the sheer amount of problems that's really added. It's an avalanche of threats. That's really the major problem.
It's unwieldy, basically.
Yeah, and then everyone's telling you got to fix everything. You got to stop this attack and that attack. You got to stop cell phone attacks. I got to stop. My web camera could be attacking me. And I say people in the book. I use the allegory or example that people see the threats like bubbles in a glass of champagne. And they just keep coming. Yep. But what they don't tell you is that two of those bubbles, what most people don't know is two of those bubbles take up almost all the glass, and the rest of them added together only add up to 1% to 10% of the problem. So, you're just being overwhelmed and nothing again, like the NIST cybersecurity framework. I love it. And PCI DSS and HIPAA and Sarbanes-Oxley and Center for Internet Security and stuff. They'll all tell you that you have to do these 200 or 300 things. And none of them say, oh, by the way, just two of the controls, fighting social engineering and better patching, is almost all of it.
Yeah.
I do like the Center for Internet Security. I love because they actually go out of their way going, hey, you need to assess your risk before you start deciding which controls. And if anybody that's got it, it's the Center for Internet Security has it right. But like PCI, they're going to have these 9 domains. And the first domain is like network isolation. And it used to be firewalls. Now they call it network isolation or something like that. But firewalls haven't been stopping the threats that we face forever.
Yeah.
Yet it has like 33 controls over 40 pages. And then fighting social engineering, which would be the number one best thing most companies can do. And PCI DSS in version 2, I think it was 3 or 4 sentences. And it was like under control 11, but it was like you had to go through hundreds of controls. I'm like, okay, if you got to do 44 controls or 33 controls over 40 pages, and then something that's 6 sentences, where are you probably gonna spend your staff's time? Well, you're gonna spend your staff's time because you're gonna be, did you pass your PCI DSS audit? Or are you PCI DSS compliant? They don't want to know that you're skipping stuff. So you've got to do it all. I don't know anybody that can do more than two or three things right at once. Yeah, I used to say, if you want to impress me, have one IT project that you finish in a given year and do right. like forget trying to do 40 or 80 things. If you can show me one project that you did the way it was supposed to do, you're getting my admiration, because I understand that they've told you have 10 number ones.
Yes.
And you're in the middle of trying to figure out, okay, which ones can I do out of the 10? And you get it down to 3. And then somebody comes in with a new idea and like, you need to implement this. And next thing you know, you have a new number 1, and you're supposed to get all the other number 1s done, but this is really your new number 1. And so the number 1 problem is the sheer amount
number
of
1 prime, number 2 prime, number 1 2 prime. Yeah, exactly.
Yeah. I mean, it's just an onslaught of it's an onslaught of attackers, an onslaught of problems. They're not telling you which ones that you really need to worry about. It's compliance, is a big deal. Like you have to comply. If you want to get something done, have it be compliant. And a lot of times that compliance is kind of faulty. It's like this fake binary. Do you patch or not patch? And and some people are like, well, I do 99% patch compliance, but the 1% they don't do is all the stuff that gets attacked all the time.
Well, it sounds like part of the root causes is there's so much that it freezes people, because it's like I don't know where to start, so I don't start. Is that sort of one of the problems that is a net result of this?
I would say that it's more that they either start trying to do everything at once, which you just can't do well because you spread too thin. They're oftentimes focusing on the wrong issues. That's a really big one, like firewalls and antivirus. A big one like lately, VPNs. Got to have a VPN. Everybody I know that's been compromised by ransomware had a VPN. It's like antivirus and firewalls, highly overrated, but you better have that VPN or you're not going to pass your audit. So that's a big one, is they're just focused on the wrong things. And if I'm assigning resources to the wrong thing, I'm at very least being inefficient. And I got to tell you, something strange about human behaviors. Even if I tell you, we go into a meeting and I convince you that you need to do social engineering and patching, something happens after that talk to where the people just forget. And I've been watching it for decades now. Like I was in a meeting with with probably one of the most accomplished women I've ever met in my life. I don't know how, it was like I was meeting with Melinda Gates or something. It was a very powerful woman. It was a woman that had she'd gone public with something like 16, 17 companies. She sits on board of directors. It's a who's who in the computer security world. Very accomplished woman that really, for a board of directors level, knew security very, very well. Like I one of the most impressive people I've ever met at that level. And I then went through my presentation saying, hey, you need to worry about social engineering and programming. And everybody was shaking their head and, in agreement. And then maybe an hour later, she was telling everybody how patching was the number 1 problem. That was the focus, patching. And I'm like, no, the stats show that, patching is a third of the problem. Social engineering 70 to 90%. Patching is important, but it's not the number 1 problem. It's the number 2 problem. And I saw even people in the room even shaking their heads. Other CEOs and CIOs and CISOs and CIOs and stuff. They're like, yes. And they'd seen my presentation too. And everybody agreed with my data. I had data from Cisco and IBM. It's not Roger's gut feelings. It's like really good data sourced broadly. And it's not. And let me say, it's never been. Patching was the number 1 problem. Even if it's a patching problem, it's usually getting to you through social engineering. The only ones that aren't getting through you through social engineering are the ones that are attacking remote services. Like, that would be like unpatched RDP or something like that. So where you have this unpatched listening service that's available to the internet, and that's a problem, but it's not been a problem for decades. Like I think Microsoft has had like 3 or 5 patching problems with remote listening services over the last decade. The rest of them require end user input, and basically you're social engineering them to click on this link that then creates this chain of attack. But there's not a whole lot of truly remote exploits in it. There are, And when there are these remote exploits, like there was with Microsoft Exchange or something, they are really abused, but there's just not a lot of them. So I'm, again, even going further back when I started writing data-driven defense, I'd say, hey, you need to fix unpatched Java. You're getting compromised to in the year that I did, I think it's 2005 or something. Unpatched Java was responsible for 92% of successful exploits. One thing. And if you patch Java perfectly, you would fix 92% of your risk in your organization. And yet every organization didn't patch it. And then I would go in and I would tell these CEOs and IT teams, you need to patch Java. And they would say, they were like, yeah, it's really hard though, because we patch it, it breaks stuff. And they had real reasons why they weren't doing it.
Sure.
But then I would come back next year and the third and fourth time, they're broken into again and again, throwing patch Java. So I was like, why are they not doing it? And it came down to being a lot of it, overwhelming number of issues, bubbles in a glass of champagne. And you're being told that you have to fix compliance issues, like because the CEO was told by Sarbanes-Oxley, they're now responsible personally for compliance issues. And that, matter of fact, I used to tell people, if you want a security problem fixed, somehow make it a compliance issue, because it's more likely to be fixed. And let me say, sometimes compliance would go against really good security. Like they would say, well, your password has to be 6 or 8 or 10 characters long and have complexity, uppercase, lowercase. Mm-hmm. But if you tried to put in a 20-character passphrase without complexity, which is far stronger than a 10-character password, they won't let you do it. So it's like sometimes compliance literally would go against you having better security. And just crazy, like the compliance would be, well, you got to make sure that you have your Windows administrator accounts accounted for, domain administrator accounts accounted for. Like literally, you'd get audited and dinged if you didn't have your credential hygiene really done well on Active Directory accounts. Mm-hmm. But how well you covered your Salesforce accounts, or any app. They never audited the admins of any application where the data is actually stored. Like that. I was like, I compromised Roger, and Roger's a Salesforce admin, and now I can get to all the data and things that Roger sees. That's never audited, and because they don't have, because it's not on a compliance checklist, no one's ever being signed to make sure I have good credential hygiene in all these applications. They're actually holding the data. It's a really strange, ironic.
Irony. Yeah, there's irony in the whole thing. Yep.
Yeah, black fly in your Chardonnay or whatever. But it was so that was one of the first things I had to address is what's the root cause of why people aren't addressing it, and it's sheer number of problems, a whole lot of things competing for your time. Yep. And then just strange human behavior, like where what you need to do, but it's the shiny thing. There's a saying in the book where, Bill Gates, Melinda Foundation, proved that there is more deaths from mosquitoes every day worldwide than shark attacks in the history of shark attacks. And yet everybody's worried about being bitten by a shark, and you have a hard time getting people to put on mosquito repellent.
Yeah. That's a great point.
Or your odds of dying in a car are really high, 1 in 50, 1 in 100. But almost no one's nervous in the car. But put them on an airplane when your odds of dying are 1 in like 10 million, and you got all kinds of nervous people, including possibly me. And it's just a weird thing about human behavior is we're worried about the wrong thing sometimes. And even if we know we're worried about the wrong thing, it's still hard to shake our humanity. So when we say root causes, there's a root cause of why we're in this problem. And it's ultimately that we're not looking at the data. We're not capturing the data. We're not looking at the data and then being able to follow the data. And then it gets to the second set of root causes, which is how are you most likely to be attacked? And to do that, I created a list of here's all the ways you can be attacked. And let me say, I created the first list like 20 years ago. And I used to create all kinds of lists. I used to go, what file attachments can be used to attack you? And I think that list got up to like 200 when I eventually, it's like every file type has been used to attack you. We're in a Windows system, could you hide to auto run? And I got us to like 120 things, and eventually that I helped Mark Rusinovich improve what's called auto runs, one of his great sysinternal tools. I was like, it's like everywhere. You can hide in a folder, you can hide in the registry, you can hide in a printer driver. And along with that, I had this, hey, what are the root cause methods? If someone's trying to break in your house, how can they break into you? Is it through the windows, the doors, the floors, the ceiling, the chimney? Because I said we need to focus on how things break in, because your problem's not, let's say, ransomware. Although back in the day when I was considering this, I think I was going through pass the hash attacks. Like my clients are saying, and at Microsoft, I was at Microsoft, they're like, you have to address pass the hash attacks. And I was having to write white papers and participate in committees. And I was like, pass the hash attacks are not your problem. It's how did the attacker get to domain admin? Like once it gets to domain admin, they can rewrite operating system code. They can rewrite Active Directory. Like literally, pass the hash attacks are the least of your problem. It's like worrying about your car or worrying about your car's brakes after they've stolen the car. I literally remember sitting me. I refuse to address pass the hash attacks. But smarter people went, Roger, if your customers are worried about it, ignore your customer at your own peril. So they talked me into addressing pass the hash attacks. Now it's ransomware attacks. I'm like, listen. Ransomware attacks are not your problem. That's an outcome of your real problem. How did they get to a situation where they're able to install ransomware? Because if I'm able to click and make ransomware go away, like, hey, there's no more ransomware, just turns out it doesn't work anymore. If they have admin access to your computers and networks, they're just going to do something else horrible.
Mm. Yeah,
wiperware, password stealing, exfiltrate your data, whatever it might be. But so I came up with, and I started keeping this list like something like 22 years ago now, called the root causes of hacking, initial root causes of how do they get it? I thought, how are they getting it? And I came up with a list. I think it was 10, and it's gone up to 15, and some of the naming has changed over the years, but really, because I just relook at, and if you saw my first list, I had mixed up root causes with outcomes of root causes. So I was the guy making the mistake and mixing things up, but I've got it pretty clear. So here's the 12 or 13 ways that all hackers and ransomware break into today. It's social engineering, number one, a programming bug that's in a software or firmware patch, either patched or not patched. It's an authentication attack. So that would be like, it could be password guessing attack, password hash cracking attack, could be some sort of pass the hash attack. It could be doing a man in the middle attack and intercepting your hashes, and from there able to determine your password. It could be some type of malicious injection and NTLM copying or something like that. Authentication attack. Then there's malicious instruction scripting, and that's basically any programming or macro language or automation language can be turned into doing bad things. So PowerShell can be told to do bad things. So I can send you a script that if you click on it does bad things to you. Data malformation. So I can malform data so that when you click or open it, it does a buffer overflow or something like that, corrupts your system in some way. Human error or misconfiguration is another way, right? That the person, I accidentally send, Jeff, I send you my personal information. I meant to send it to my brother, Jeff, but I sent it to Jeff Edwards, and now you have my data. I just made a mistake. Or misconfiguration. A really common misconfiguration is overly permissive permissions. Like everyone has full control. You'll read about these. It used to happen a lot with Amazon data buckets, because by default, when you created a data storage bucket on Amazon Web Services called S3 buckets, the default permission was everyone full control. And then they got, well, that's crazy. We're going to do everyone write or everyone read. But, so it's still, there's all these buckets to this day that you can go out to and anybody can access if you actually stumble upon the URL. Luckily today, it's not that open, but, that's the other thing, right? People take defaults a lot. Okay. So that human error misconfiguration was one. Eavesdropping, man in the middle attack. So that's eavesdropping in some sort of communications. Maybe you're eavesdropping on a password or a password hash. You're able to inject yourself and change the message in some way. Side channel attack, so side channel attack, that would be like maybe you have a smart card. And if I get your smart card, I can actually measure the wireless signals EMI, the wireless signals coming off of there will actually tell me, can translate into ones and zeros, and I can figure out what it is. Or information leak,
Yeah.
It's funny. You always see these research projects where I'm focusing my sound waves on the light bulb in your room, and I'm able to read what your password is when you type it, or the windows, the vibration of your windows. Every time you type your password, I can tell what letter you're doing. There's all these side channel attacks. Side channel attacks, they're always a really great spy novel, but they
Yeah.
just they're not used in real life. Brute force computational attack,
Mm.
that's where I don't guess at your password, or maybe I'm guessing at your password, but computation, I'm just going to keep going until I find out what your password is, or I get your password hashes and I decide that I'm going to, figure it out. I'm brute forcing my way through whatever the secret is. Maybe I'm brute forcing your secret key or your password. That's another way of doing it. Network traffic malformation. So that's kind of like data malformation, but I meant that more for like distributed denial of service attacks, where I'm creating, malforming a EMC echo reply or something, IMCP echo reply, so that it causes some type of relay attack or something. Insider attack, someone you trust inside that's doing something bad. And then third party reliance issue, that's a little bit of everything, a catch all. So that's like supply chain attack, vendor attack. I have a customer that is, accessing my database and stealing information. So that's third party reliance. A lot of people, as a matter of fact, I'm getting ready to write an article on that soon. On, many companies, big, large companies with big databases, they have customers that are just malicious. And, like you go on the internet and say, I want to learn everything about Jeff Edwards. And it's illegal for me to be able to access a law enforcement system to learn everything about Jeff Edwards. But there are plenty of nebulous companies that are in those systems that can pull up everything for Jeff Edwards, or they belong to the Visa system, the MasterCard system. They can pull. That's how they're getting the information. They're just rogue customers. So I call that third-party reliance issue. And the last one is physical attack, right? I can just steal your laptop, steal your USB key, whatever. So I have those 13 types. I said, okay, and I've refined them over 2 decades. I really think I have a pretty solid list, but I always invite people, tell me if I've missed something, right? But that's step one, is find out what are all the ways that you can be attacked. And then step 2 is figure out what are the ones that are most likely to compromise you. And then from there, start creating your defense plan. So that's the root causes. Root causes, real quick to go through them again: social engineering, a programming bug, an authentication attack, malicious instructions or scripting, data malformation, human error or misconfiguration, eavesdropping, man-in-the-middle attack, side channel or information leak, brute force computational attack, network traffic malformation, insider attack, third-party reliance issue like supply chain attack, or physical attack. And I invite anybody here in this podcast, if you think I've missed something, please send an email to Jeff or me, and would love to hear it and update that list. I'm not perfect, and sometimes I miss stuff, but I've tried not to.
Well, at least you went from 200 and some on a scroll down to a list that's manageable.
Yeah, and so now I know, okay, here's all the ways that someone could break into my house, or in this case, a network device or a network. And then okay, now we got to figure out what are the ways that are most likely, and then start implementing that.
Yeah, and then take your resources or your time or whatever and focus in on the 2 or 3 things that you can accomplish and start from there, I take it.
Yeah, no, you're exactly right. Because you're not going to, I'm going to close all 13 holes, right? That's like saying I'm getting rid of all crime at once. It can't be done. If you tackle well 2 or 3 things, you're going to be elite. If you go into your company and tackle 2 or 3 things, you're going to be an elite master cyber defender, simply by focusing on 2 or 3 things. Let me say again, those 2 or 3 things are 99% of the problem. Yeah. And if you focus, whether or not you get hacked is how well you focus on the right things, right? That's what it comes down to. And let me say, everyone's like, well, maybe I get compromised by SQL injection or something like that. You could, but you don't send an army into battle telling them to focus the resources on the thing that's not likely to happen.
Yeah.
You want to send them into battle saying this is how we think the battle's going to go down, and this is how the guy's going to fight, and you need to put all these people on the right flank, and you need to have these weapons here, and we think it's going to happen here.
Yeah.
And then you change your strategy if you learn something different, but you at least start out with a plan of how you think it's likely to go.
So basically, stop for 2 seconds, assess where you really are, look at these 12, 13, or whatever the number of things, and say which ones are most likely to happen to me. Invest your limited time on getting the ones that are most likely to get you. And you are, as Roger Grimes said, one of his heroes, a cybersecurity hero, basically. Is that what is that what I heard? All right.
Yeah, that's exactly. And let me say, it's very difficult because you're going to be besieged by you have to do these 200 or 300 things all at once, right? And you have to do this thing and that thing and make sure you have VPNs. And, like I have people go, what antivirus should I run? I'm like, It's not as important as it used to be. But let me go further. If it was really important, like if we actually, the antivirus people say, I detect 100% of malware. It's a lie. If they did it, we would have solved this problem a long time ago. You wouldn't have to memorize my list of 13 things.
Okay, so let's start there. Let's say, let's take 13 things and get the one or two off just get those done, and you are a long way down the road. Now, as we prepare and kind of wrap up our, root causes discussion, we're going to move into the, the mental maps and the operational frameworks. So now that we have kind of a basis in which to say, okay, everybody calm down just a little bit, stop being so distracted, focus is key, align your resources on the one or two things that you think could happen to you, and forget about all the noise, focus for just a little while. Is that pretty much it?
And let me say, and focus on root causes, not the potential outcomes of root causes. Like, that's part of the problem is I see a lot of data out there and they'll say, why did I get broken into? Ransomware.
Yeah.
Why did you get broken into? Credential theft. Credential theft is an outcome of a root cause. How did your credentials get stolen? It's one of these other 13 things. Was it social engineering? Was it unpatched software? Was it stolen from a database somewhere? And if it got stolen from your third-party supplier, how did they get into the third-party supplier? Right? You got to go upstream. So that's what it's focus. It's focus on initial root causes. And then also looking at the various risk out of the 13 that it could possibly be. And let me say, we know the answer for most people today, but it's not always going to be that. So you have to, as you talk about, have this mental mind map that helps you figure out, okay, how do I approach it? Because it's going to change over. Hopefully one day, social engineering will not be the number one cause. And if so, how are you going to make sure you update your mental mind map? So,
excellent. Well, Roger, thank you so much. As always, it's a delight. Thank you for your insights and your guidance. So let's wrap this episode with a warm thank you, and looking forward to moving on to our mental maps on our operational frameworks.
Sure.
All right. That's our podcast for today. I'm Jeff Edwards for the SafeHouse Initiative. Thanks for joining us, and remember, be safe, be resilient, and be kind to each other. For more information on the SafeHouse Initiative, please use your mobile device to scan the QR code on the screen. Send us an email at safehouseinitiative.org@gmail.com, or visit us on our website, safehouseinitiative.org. We look forward to hearing from you.